Welcome to Claire's Chemistry Corner. My name is Claire Flint-Anderson, and today I'm going to talk a little bit about bomb calorimeters. Because damn, those calorimeters are really bomb. So, anyways, what is a bomb calorimeter? So a bomb calorimeter is just another type of calorimeter. It's just a type of calorimeter that's more complex, and I'll get into that a little bit later. So let's just step back a little bit and actually talk about what a calorimeter is. A calorimeter is essentially just a container used to measure heat flow. It's used when, because heat is really hard to measure. If I'm in a hot shower and the heat from the shower is absorbing into me, it's also absorbing into the room and the shampoo bottle, and it's just bouncing everywhere and it's going crazy. It's like your drunk friend at a party, okay? You have to contain it somehow, and in this case, it just happens to be either in a bomb calorimeter or in a styrofoam cup. So that brings me to my next point. So there are two types of calorimeters, and the most simple type, which is really what we work most with in high school chemistry and in labs, is a coffee cup calorimeter. And a coffee cup calorimeter is literally a coffee cup in a beaker. It's really nothing special. So your insulator, what keeps the heat in, is the styrofoam cup. And styrofoam is actually an excellent insulator. That's why they use it on coffee cups. And your environment is water. And for this one, what's really important to note here is that the heat of the water equals the heat of the calorimeter because that's your environment, that's what it's in. So if you ever have a substance that can't directly touch water, like it'll dissolve or something of that ilk, you can use this coffee cup calorimeter. It's a very simple calorimeter and the results actually work out pretty well. So this brings me to the bomb calorimeter, which is the it's the most complex of calorimeters. So a bomb calorimeter is basically used to study the heat of combustion reactions, hence the, bomb in the name, because it's an explosion. So what a bomb calorimeter is, it has, a double boiler. Like if I was to melt chocolate for frosting, what would I be melting chocolate for? For frosting? Maybe, probably. So if I were melting chocolate for frosting, I would have my pot, and I would have another bowl on top of it to melt my chocolate in. So this is pretty much the same thing. So there's a big tank with a smaller tank in the big tank. And it'll let me just go over to my whiteboard so I can. Let's talk about one thing this experience has taught me. Number one, rig up a better system to show you pictures. Okay, so a bomb calorimeter looks like this, and this is obviously an extremely accurate representation of what a bomb calorimeter is. As you can see, I am a professionally trained artist in the field of calorimetry, obviously, but that's beside the point. I don't like to brag. So what a calorimeter is, it's essentially, like I said, it's a big pot with a smaller pot inside the pot. Welcome to Colorado. So anyways, so this right here is your water. This is your environment. This is what the calorimeter is in. This is pretty much what you're going to find in all calorimeters, is water is your environment. This obviously is your thermometer to measure your delta T, which you're going to need for your Q equation, which you already know. This, however, okay, so let's just talk about the smaller pot right here. So this little spoony thing is just basically what you place your chemicals on. It's just a little, dangly thing that you place your chemicals on. But this, however, is an exposed live wire attached to a battery up here. And what this battery does is, because calorimeters measure the heat of combustion, it starts the combustion reaction. So because you probably can't do it yourself because it's going to explode, it starts the combustion reaction so that it can be measured by the calorimeter. But obviously calorimeters aren't perfect. They're machines. There's got to be something that is limiting them or something that is wrong with them. So calorimeters have a thing called heat capacity, and this in your Q equation, your equation is going to be the Q of the calorimeter equals the change in temperature, delta T, times the heat capacity, which is abbreviated as CP. Why? I don't know. Scientists are weird, man. You know, they like have all these equations. It's like, oh, screw you, we're gonna make this extremely hard. So that's what they did there. So the heat capacity is essentially, it's like specific heat. It's the amount of heat required, this is usually in calories, needed to raise the system's temperature by 1 degree Celsius. And usually it's in Celsius, but it can be in Kelvin. So this can limit that because it's different for all machines. Some machines could take a higher amount of calories to raise their degree 1 temperature, while other machines could do it more easily. So now you pretty much know everything there is to know about a bomb calorimeter, and I will see you guys later. Thank you.